then I will
Yep.
send you the link. I'll post it on my YouTube channel and send you the link on how to watch it.
All right.
Okay. So the first format they generally teach you for quadratics is this one. It's called vertex format. You know what it is?
I don't think so. Here.
Okay. It's x minus h squared plus k. And
No, for that.
okay, well, the value of this is that it immediately pinpoints the vertex. In other words, the most important part of any quadratic is that part right there, because that's where
Uh-huh.
either a minimum occurs, or if it's an upside down parabola, that's where a maximum would occur. So it is
Uh-huh.
without a doubt the most important part of the quadratic is finding the vertex. And if you are given an equation such as y equals 2x minus 3 squared plus 4, if somebody gave you that equation, you would be able to graph it quite quickly because you know where the vertex is. Where's the vertex? Incidentally, the h is the x coordinate of the vertex, and the k is the y coordinate of the vertex.
-3, 4.
Actually, because it's x minus h is the general, then h here is positive 3.
Uh-huh. Okay, so
So the
positive.
vertex would be right there at 3
Mhm.
comma 4. And because a is positive, it's a positive 2. We know it opens up. So it's going to look something like that. The only thing we don't
Yeah.
know is whether uh, it could be like this, or it could be like this. In other words, we know where the vertex is. We just don't know whether it's normal, skinnier, or fatter. And that is a vertical stretch factor. Do you remember your transformations in algebra?
Um,
There's 6 transformations. They're called vertical stretch, vertical shrink, vertical shift, horizontal stretch, horizontal shift.
oh yeah, I don't know if I quite got to this
Okay,
in my,
we'll want to go over that also.
yeah, I remember I
Trans
wanted to go over the
transformation.
parabolas because I
Uh-huh.
didn't do the best at those.
If you look at this as a transformation, this is a vertical stretch factor. So that tells me that this parabola, that instead of being the normal one like this, that it would be skinnier. In other words, every point is going to be twice as far away from the x-axis. So this point here, which is this distance to the x-axis, because we're
Yeah.
multiplying by 2, it's going to be way up here. And the net effect of that is you end up with a parabola that's skinnier.
Hmm.
So vertical stretches change the shape of the curve and they make them skinnier. If this 2 were a number less than 1, let's say 1/2, it would make it flatter. It would
Uh-huh.
be more like this if you can see my cursor.
Yep.
Okay, so um, by knowing that, in other words, you can see how valuable this vertex format is.
Yep.
That's the format you want to get it into, even if they haven't given it to you. There are a couple of other formats that are also quite useful. Another one is this one. This is called x-intercept format.
Yep. Okay.
This one's vertex. And in x-intercept format, what P and Q are the intercepts. So P is that one, Q is that one. And if you were given an equation that wasn't in vertex form, go ahead.
And you would need the vertex in order to find
Not
the,
necessarily. Let's say they gave us an equation that looks like this. This is not in vertex format. So we could multiply it out, but that's going to put it in standard format. There is one other format. Let's call it standard. Let me write it up here. And this is the way you usually get most of your equations when they give it to you. In other words, they
okay.
might give you y equal 2x squared plus 3x plus 4, which is in neither vertex format nor x-intercept format. So when you get an equation that's in standard format, you have to mess around with that. There's various ways to find the vertex. We'll go through each one. But there are three formats for quadratics: vertex, x-intercept, and standard. The reason standard's the third one is because the x-intercept format is pretty good, because if you know the intercepts, you at least know the x coordinate of the vertex is halfway between those intercepts.
Mhm.
So if I know here, if I graph this one that I've given you here, I know that my x-intercepts are at 2 and 4. So the parabola looks something like, I know it opens up because that A is the same. This A is the same as this A. So if we
Mhm.
have a positive A, it opens up. If we have a negative A, let's say this was a -3, then the curve would look like this.
Mhm. Okay, so pretty easy. Positive opens up, negative
Yeah,
opens down.
very straightforward, right? And now we know that this is 3 because it's halfway between 2 and 4. So the way you find the x coordinate of the vertex is you add the two x-intercepts together and divide by 2. So 2 plus 4 is 6, divide by 2, 3. And that handles positive and negative numbers easily. So if I want to know the y coordinate of the vertex, then just plug in 3 for x. And the y coordinate would be -3.
Mhm.
You see that? Why?
Yeah.
Because it would be 3 times 1 times -1. So the y coordinate's -3, pretty easy to find. So x-intercept format is a valuable format because you can easily find the vertex. And additionally, you find the x-intercepts. And 3 points define a quadratic or a parabola. So once you have 3 points, you don't need any more. You can draw the parabola. You might find some teachers that will ask for 5 points, but that's really quite unnecessary. Any 3 points define a parabola, including if they told me I had a parabola and they give me 3 points, one there, and one there, I can come up with the equation of that parabola. So any 3 points define a parabola. And in our last case with this last equation, we had the two x-intercepts and we found the vertex. Relatively easy. Now there's another thing called the axis of symmetry, which doesn't show up on the graph, That's why I'm making it a dotted line. But the axis of symmetry is basically the vertical line that runs through the x coordinate. So they will sometimes ask you for the equation of the axis of symmetry, and it is a line and it's not a point. So the equation of vertical lines is always x equal, and in this case, it's x equal 3.
Uh,
Okay. So if you get your equation in vertex format, you can go to work on it. If you get your equation in x-intercept, you can go to work on it. But what they'll frequently do is give you the equation in standard format.
and
Let me
that's
show you how
so
to handle that.
okay. And then is there a way to where like if you get it in once you get it in standard form, you can pull out the vertex or x-intercept
Yeah,
out of it to simplify things?
there's two ways to proceed from here. Let's give us a real one here. Let's say they give you that and they ask you, the typical question would say, find the vertex, the axis of symmetry, and then graph it. Well, there's a relatively easy way to find the x coordinate of the vertex. And let me show you how to do that. And the way I write that is I write vertex sub x. This is going to give us the x coordinate only of the vertex. And that's always minus b over 2a. And if that's difficult to remember, relate it back to the quadratic formula. You know the quadratic, I remember. What is it?
The quadratic is hold on, I've got it. Is it the ah, negative b plus minus square root b squared um minus 4ac and then all over 2a.
There you go. And the reason I referred to this is notice the first half of the quadratic is our minus
Yep.
b over 2a. So
Uh-huh.
if you have the quadratic memorized, you can always figure out what that is. And if you don't have the quadratic memorized and you have this memorized, then it helps you in figuring out what the quadratic is. So they kind of go hand in hand, or one is useful for the other, I should put it. Okay, we're not going to use the quadratic. We're just going to use it to figure out where the vertex, the x coordinate of the vertex is. So that's A, that's B, and that is C. And actually, I did that wrong. That is B, including its sign. So if we plug that in, what do we get?
Um, hold on, I got it. B and C. And wait, I'm plugging it into the
To this
negative
right
b.
here. Yeah.
Okay, so then we'll have negative 3 over 2 times 2. So then we're gonna end up, yeah, negative
Yeah.
3 over 4.
And notice how quickly we were able to come up with it. It doesn't even use C. So
Yeah.
that's the x coordinate of the vertex. And now if I want to find the y coordinate, plug it into our equation down here, minus 3/4, and it'll tell you the y coordinate. So unfortunately, I pulled this one off the top of my head, so the numbers aren't going to be round or whole, but nonetheless, it's not that hard to do. So if we plug that in and square it, it becomes what?
Um, so plug in -3/4.
Uh-huh, for x. In other words, we're trying to figure out what the y coordinate is.
So 2 times -3/4 squared and then -3/4
The 2 is
squared.
not being squared. So you have to square the -3/4 first and then multiply it by 2.
That would be my brain is blanking right now. Uh-oh.
Okay, if we square that, we get 9, positive 9/16.
Oh, yeah, I'm not sure why I just blanked on that.
And then multiplying it by 2, we get 9/8.
Yep. Wait, not sure why I just blanked there.
That's all right.
And
Plus
then
3
plus
times that is going to be a minus
pl
9/4 minus 4. So
yep. And then
we don't need to review
no,
arithmetic.
yeah.
So that would give us the y coordinate of the vertex. And so we found the vertex, the most important part. Uh, Now, there is another technique that is worth showing you that
Oh, I forgot. I had
you
to tell
might
you
find
about.
easier. Well, go ahead.
I had a question for you. So
Sure.
my dad wanted me to ask you this. So there was a point. So when the rest of my class was learning like multiplication and long division, I was being pulled aside to do the ESL courses because my
Uh-huh.
first language is in English.
Right.
And so I missed that huge section and I can do multiplication and division. It just takes me a minute because I wasn't in class when like when I was taught the tips and tricks. So like
Here.
during our next
Let's,
lesson, could
yeah.
we just do like a quick
Here.
review of
I'm
that
gonna,
like during our next class?
perfect. I'm going to show you exactly here where to go to practice. For-
Because I can do multiplication, but because the stupid
No,
ESL.
this is going to be really good for you. Let me make sure I can find it. It's flashcards. There's so many things on here that. There, I saw it. There we go. Okay. So these are like digital flashcards. And what they do is they combine, it's all addition, subtraction, multiplication, and division with positive and negative numbers. And it's amazing how many students I get that can't do this very well. They've grown up completely dependent on their calculators. So we'll go through these. You holler out the answer. I'll type it in and we'll see how good you are.
All right.
Yeah, no pressure. I mean, seriously, just you tell me what you think the answer is.
All right. Okay, starting this one.
Uh-huh.
Okay, -7.
Okay. And then it gives you another one immediately. And it
Okay.
does it randomly. In other words, they don't do a bunch of addition, a bunch of subtraction. It's either addition, subtraction, multiplication, or division. So what's this?
That is 14.
Okay, and you want to be able to you want to be able to do these as quick as you can. So when you're practicing, you want to make sure you're accurate and you're fast. One,
-32. So,
negative 32, okay.
um, okay. Um, that is 56. Yeah, 56.
Good.
7.
Okay. These are the ones that throw a lot of my students. This one right here.
-2 minus 7.
Hmm.
That is -9.
Good. So looks like you're pretty good. Maybe your speed could use a little bit faster.
That's the problem. It's the speed. And then it's like once we get to like the bigger multiplications, once it's like, or
When you
once
when
we
you
get to like the
multiply,
hundreds and the thousands and the tens of
yeah, you
thousands.
don't need to worry. You can use your calculator there just fine. Um, the reason it's
Like,
really,
this is 35.
yeah, the reason it's necessary to be proficient, accurate, and fast is because when you start solving equations, you usually have like 6 to 10 steps that are each one are just doing single digit arithmetic. Like
Yeah.
move one number to the other side of the equation, that's a single digit subtraction or addition. And the
Mhm.
faster you are, the
Could you send me
more,
the link to this? Or
yeah,
is
can you see it up top?
yeah.
Uh,
Um or
let's see, what's the
have
best
any
way for me?
apps?
I can copy and paste that and send it to you to your email.
Are there any websites that can help with like the bigger,
Uh,
like the larger number
I
ones?
would
Because my
recommend using
dad
your
and I will be
calculator. If
talking.
you're doing 12 times 14, use a calculator.
Okay, because my dad and I would be talking in the car, and then he'd ask me a math question that's like usually long division, and it'll take me a minute, even though it shouldn't.
Like like 56 divided by 7.
No, bigger than that, like in the hundreds.
Okay. Those you want to use a calculator. I would use a calculator. I wouldn't
Okay.
try to do those by manual. In other words, the calculator is a tremendous tool when you have numbers that you need a calculator to do, as opposed to doing it manually on a piece of paper. But it's extremely negative if you get so used to using a calculator that you forget what 7 times 8 is. So you
Yeah.
don't want to get to that point. You want to be proficient. And this is the only website I know of that lets you work with both positive and negative numbers, all four things: addition, subtraction, multiplication, and division. So this is a wonderful one. I've copied it, and here, let me real quick send it to you so I don't forget. Um, let's see. If I type in Mila, it's not gonna. What's your email start with?
Amelia,
Amelia. Okay, that's your email.
AMILI.
There it is.
Yeah,
This
Amelia
one right
Nurseberg
here.
at gmail.com.
Okay. So let me put that in here. There's the link, and it's flashcards. And yeah, you can't go wrong by spending 5 minutes a day on this just to refresh your abilities. And you will find that you get really good and really fast, really quick. So it won't take much for you to
All
get
right.
more proficient at doing arithmetic. All right. So we don't need to do any more of these now. I've pointed it out for you, and you can work on these on your own. You know how to do all of them, I can tell. So let's go back to our page, and let's talk about a second way to handle when you're given an equation in standard format. Let's go
Oh,
back.
just got the link. Thank you.
What's that?
I just said I just got the link. Thank you.
Oh, you're welcome. No, that is a wonderful site. I can't express how useful that is for a lot of my students. If we have something like this,
All right. Hold on, let me. –
And I said, okay, find the vertex of this and graph it. Now, first of all, I can recognize that that quadratic is not factorable without the quadratic formula. It's not whole numbers. So I can't put it in x-intercept format easily. If I could factor it, I would do so, and then I would have it in y equals x minus p times x minus q. And I could go and find the vertex virtually right away. But it isn't. So there's a process called completing the square, which you're going to be taught in algebra. And it's useful in a number of occasions. And when you get to conic sections, you're going to need it. It's also very useful in taking standard format and putting it into vertex format. And here's how you do it, basically, is you group that together and you kind of leave that off to the side. And I'm going to put parentheses around this. And I'm going to leave space to complete the square. So the most important thing you want to pay attention to when you're doing these kind of things is that you do not change it from line to line. In other words, what I have written with the parentheses here, that line is exactly what I started with. I've just added some parentheses. And what I want to do is I want to complete the square inside the parentheses. And the way you complete the square, have you learned completing the square before?
I think so.
Okay.
Once I see it, I'll know. I think.
Okay. What you do is you take.
Also, sorry, give me 1 second. My dog is barking like crazy right
No, go
now.
ahead. Go ahead.
Sorry.
It's all right. Okay, so let me do this first one, and then, so I'm going to take half of 6, and then I'm going to square it. So half of 6 is 3, squared is 9, and I'm going to write plus 9. Now I've changed the form, now I've changed the line. So to balance it, I subtract 9 from the same side of the equation. So now I can write this as x squared plus 6x plus 9 minus 19. And because I use the completing the square by taking half of that coefficient and squaring it, guarantees that I can write this as a linear factor square. In other words, you're always going to be able to write it as that. And then notice what we have now. We have it in vertex format. So by completing the square, we immediately get it into vertex format and we know what to do from here. Where's our vertex?
The vertex is 3, negative
No,
19.
remember the standard is
Oh,
x minus a. It's
yeah.
always going to be
Negative 3, 19.
yeah. It's until you hit calculus. In geometry, algebra 2, trigonometry, every time you have a general equation that has like an x and an h or an x and a k, it's always minus. Just kind of remember that. And it won't be until you hit calculus that you ever run into an x plus h. Okay, so the vertex here is minus 3 minus 19.
Yep.
And a is 1. So to graph it, I just go to minus 3 minus 19. I know it opens up. It's not stretched or compressed. So it has basically that. Now, I don't know where those points are, and those are the two most valuable points to find next, but I can easily find it because I know those occur when y is 0, right? So to find those 2 points, I've already found this point, but to find these 2 points, I just make y equal to 0 and then solve this equation, which is easy enough to solve. You move the 19 over, take the square root of both sides, and then subtract 3, and you've solved for both zeros.
Mhm.
Okay? All right. So let's do, I'm going to give you another one, and let's have you complete the square this time.
All right. Might do this wrong. She probably
It's
will.
all right. No, it's the way this tutoring works is I show you how to do one, and then I give you a bunch to do, and until you get them, you know how to do them.
Mhm.
So this time we'll use 8x minus 5. Now,
Okay,
first of
so
all, first of all, we want to take a quick look and see, could I factor this easily? In other words, is it going to be x minus 5 times x plus 1? No, that doesn't produce a plus 8 there. And those are the only factors of 5. So that
yeah,
immediately tells me that I would have to use the quadratic if I wanted to solve this for the zeros. So I have two choices. I can use the minus b over 2a to find the x coordinate of the vertex, but there was quite a bit of math in that because I have to solve for minus b over 2a, and then whatever I get for an answer, I got to plug it in for x and then solve for y. So there's a lot of arithmetic to do if you use that
but
method.
that one, I don't know why, but that one makes more sense in my mind.
It does, but you'll see that this is actually easier. And I want to do this one because you're going to need the complete the square skill for numerous areas in math. So it's something you want to get good at. And once you're good at it, you'll always complete the square as opposed to using the minus b over 2a. So to complete the square here, first I'll get you started. Leave room
Um,
to complete the square. Put the minus 5 out there. So how do you complete the square inside the parentheses?
you hold on. I believe in myself. And
What do you do to this?
don't you make it negative?
You take half of it and then square.
Um, yep.
So what's
Um,
half of 8 squared?
16.
Okay. And you're always adding. Even if that's a negative number, you would get negative 4 squared, which would still be positive 16. So you're always adding when you're completing the square. And now to balance, what do I have to do over here?
Then you have to holy moly guacamole. What is
You
that?
have to, we don't want to change it. And I just changed it. I added 16 to the right side of the equation.
So
So,
then
how do I balance it? By subtracting 16.
hmm,
That's straightforward.
yep. Oh my God. I don't know
Now,
why I'm thinking so much right now. I'm like a
now,
puke
that's okay.
fart.
Now I can write that as a monomial term squared, and it's always going to be x plus whatever I got when I took half of that. In other words, this becomes a perfect trinomial. By
Mhm.
perfect trinomial, I mean it's a linear term squared. And that's the whole point of completing the square, is so I will be able to write it like that.
Mhm.
And now combine those two, you get minus 21.
Yep.
Now we know the vertex. The vertex is where?
-4, -21.
Correct. And then we can go from there. So completing the square, let me give you one more. This one I'll make a little bit tougher. Okay. First step.
Okay, so what you're gonna, not you, what I'm gonna do is do half of 5 squared.
Okay.
So 2.
Well, now there's the first thing you want to do is you want to leave it as a fraction because it's easier to square 5/2 than it is to square 2.5, right? 5/2,
Yeah.
you just have to square the top, square the bottom. 2.5, that's hard to square.
So then 25/4.
Yeah. And it's always plus 25/4.
And then 25/4 minus 5.
Well, I'll do it like this.
Yeah, -5 minus 25 over
I
4.
I actually am used to doing it. I like doing this way better than putting that minus 25/4 below it, which is more the standard way. The reason I like it is because I've spent so much time with those digital flashcards that all of the questions you get are horizontal. In other words, that remember that -2, -7? It was
Yeah.
horizontal. It wasn't -2, -7 like that. So I like doing it horizontally because I know exactly how to do that one. Okay, so how can I write this as a perfect linear term squared?
Um, x squared. Oh no,
Well,
x. Ignore what I just said. X plus.
because of that, whatever that sign is, this is going to be the same sign.
Would it be here? Would I do 2.5 or 5
5/2.
halves?
Really, in math,
Plus 5 halves squared, and
yeah.
then minus. But then here it would be easier to subtract 2.5.
Well, yes and no.
Then
I
it'd
can
just be two
make
and a
this
half.
20/4. And now it's easier to do it. That's minus 45/4.
And then the vertex is -5 halves minus and -45.
Yeah, and if you
Um,
want to turn that into 11 1/4, that's fine. Or I prefer to leave all my math. When you first learn math, they call this an improper fraction. And the
yep,
proper fraction would be that, which gives you the impression that you're always better off using proper as opposed to improper, but it's actually the exact opposite. You're always better off with that than you are with something like that because you don't know what you're going to have to do. If you have to feed that answer into something else where you're multiplying by another fraction, it's much easier to work with it when you have this ratio as opposed to a proper fraction. Mixed numbers are difficult to do the next step, whatever might be called for. So I much prefer minus 45/4 to 11 1/4. It's personal. You can do it either way, whatever you're more comfortable with. But when you get to trig is all about ratios, and you would never want to give a trig answer as -2.5. You'd always want to give it as 5/2 because trig is all about ratios. So another reason to use improper fractions as opposed to proper fractions. All right, so that was harder because when we took half of this coefficient, we had a fraction, and then we had to square a fraction and subtract a fraction. So it was 1 degree harder. Now, there's one last thing I want to teach you about completing the square, because this is a skill you're going to need not just for working with quadratics, but when you get to conic sections, you got to do a lot of completing the square. So this time I'm going to add a 2 there, something other than a 1. And I'll make it easy again. So we'll do that. And we'll leave it like this. So when you complete the square here, you cannot complete the square unless this coefficient is a 1. So if I want to complete the square, I have to factor out that 2 from the parentheses.
Hold on.
You with me? And you can see
Yeah.
that I have not changed it. If I go look at this top next row, it's the same thing as I get if I distribute that 2 now. And it's the same thing as at the top or the second row. So in math, it's usually a good idea to check as you're going through the steps, because if you make a mistake and you wait until you get to the end, you'll never know where you made the mistake without starting at the beginning again. Whereas if you check as you go along, you'll pick up little math errors that might be made. Okay, so here, let me that a little. Oops, I meant to put it over here. Okay, so now we can complete the square. Go ahead.
And then wait, what wouldn't I have to
I'm still going to complete the square inside the parentheses because we've gotten rid of the coefficient that was not 1.
and then to complete the square, what are those steps again? Is it the same thing we did last time?
Exactly.
With
Take half of that
okay, cool.
and
So
square it.
have three, one or three halves.
Correct. Square that.
Yep. And then 3 halves squared is 9/4.
So how much did we just add to the right side of the equation when I wrote that 9/4 in? Because that's what we have to balance with, is the amount that I increased the right side by.
Like
It's not 9/4.
2 1/4.
Well, that 9/4 is being multiplied by that 2. So I actually have added 9/2 to the right side of the equation. So I have
Hold
to
on a
balance.
second.
Okay. In other words, here, let's do it step by step. At this point, it's the same as the above line, but I'm going to write in there 9/4. Now, how much do I add by writing 9/4 in there? I've added 18/4, right?
Yes.
So I have to subtract 18/4.
But it's 9/4, not 18/4.
It isn't 9/4. That 9/4 is being multiplied by
Oh,
2.
okay. Awesome. I'm not sure why that
Okay,
didn't cross my mind just now.
that's okay. That's
Okay,
okay.
cool. All
It's a
right.
little tricky. That's definitely a tricky spot. Whereas when you have to factor a number out in order to complete the square, you have to make sure that you balance by this, whatever you wrote in here, times whatever number you factored out.
And wouldn't -5 minus 18/4 just be 2/4? So 1/2? Because -5, -24.
No, if I turn my -5 into 20/4, which is the way I would do it,
Oh, it's -20.
it's minus
Okay,
38
-38
fourths.
fourths. Yep. I didn't account for the
Okay,
negative.
so here's our final answer. The 2 is out front. That's A. Remember, our vertex
Yep.
around that was A times X minus something.
Hmm.
In this case, it's X plus something because that's a plus.
X
And
plus 3/2
there
because
you go.
and
Square
then square
minus
minus
30.
38/4.
And now you have your vertex. Not only do you have your vertex, but you know what A is.
Mm-hmm.
And A is a vertical stretch factor. So instead of the parabola looking like this, it's going to look more like this.
It's gonna be skinnier.
Yeah.
Yeah.
And if that was a 3, it would be skinnier still.
Yep. But then if it
If that
was,
was a 1/2, it would be
it'd be
flat.
wider.
Yeah,
Yep.
here you go. Okay. So let's do one more. We didn't get started at 5:30 because I was late by at least 10 minutes. So if
Yeah, we
you
can start
got
at like
time, I can
5:40-ish.
go another 10 minutes for sure.
Yeah, definitely.
Okay. So what if
Uh,
this
what
is
if?
not evenly divisible? In other words, let's make that a 5, and just so we don't have similar numbers, let's make that a 7. Okay. So normally you're taught that you can only factor numbers out if they divide evenly. Well, not so when you're completing the square. First of all, I'm going to do that. I cannot complete the square until that 2 is gone. So whether 5 is divisible by 2 or not, I still do it. Leave room to complete the square. Now you
Yep.
can tell that it's the same as what I started with. You can tell it by just multiplying this 2 back in, and you realize you get the same thing we started with.
Uh-huh.
Now you're ready to complete the square. Let's do it one more time.
All right. So half of 5/2 is, wait, wait, but that doesn't,
I'll leave it as a ratio. So if I multiply 5/2 by 1/2, that's how you take half of it. It becomes 5/4.
oh, okay, yeah.
So you can just multiply the denominator by 2. So 5/4 squared is, and when it's in a ratio, it's much easier to square. You just have 2 numbers you got to square.
Yep. Okay, so then 4, no, whoa.
Square 5/4.
Yes. 25/16.
Okay. How much did I just add? Did I
Um,
balance?
50/16.
You could do it like that. I tend to want to make that 2 cancel with the 16 and make it 25/8, just to keep the numbers smaller. I'd rather work in eighths than 16ths, right?
Yeah. Yeah.
Because I'm going to have to turn that 7 into some number of eighths, which is much easier to do than turning it into some number of 16ths. And that would be 56/8. Another
Um,
situation where knowing your basic arithmetic is really good.
yep.
And so what do we have for a final answer here?
So what we have is 2x plus 5/4 squared. And then 31.
Remember when you have a minus number and another
Oh,
minus number, it's
how
the
do I
same as
keep
just
doing
adding
this?
those two
Yeah,
together.
56 plus 25, where you would have 81 over 8.
There you go. Now you're done.
Yep.
So I've covered all of the hard parts of completing the square. There's real simple, and then there's next level simple, and then this is about as hard as it gets, where you have to factor out a number that does not divide evenly into that, which leaves this fraction, which makes it even harder to take half of that fraction and square both of them, which leaves that fraction. And then it makes your arithmetic a little more difficult. But the process, they won't get any harder than this, where you just have to factor out whatever that number is. If it was a 2 or a 3 or a 17, doesn't matter. You just factor it out and you turn that into whatever it becomes. In this case, it became 5/2. If this would have started with a 17, then this would have been 5/17 in the middle. Okay? All right, so we've covered completing the square. We've covered the 3 basic formats for quadratics. No matter which format they give you, you can figure out the vertex, the axis of symmetry, and the other questions they would probably ask is, what are the x-intercepts? So let me give you one problem.
All right.
So, and they'll give you this and they'll ask you, where's the vertex? What's the axis of symmetry? And what are the x-intercepts? So where's the vertex?
The vertex is going to be 3, -4.
Where's the axis of symmetry?
Um, Shoot, I don't remember this one. Ah.
The x coordinate. It's the
Oh,
vertical line,
-3.
actually positive.
3.
Remember,
3.
x minus h. So it's whatever this is, but
Okay.
it's not a point. It's an equation of a line. So it's x equal 3. That's the axis of symmetry. So
Oh, okay.
if I was going to graph that, I would start at the vertex, 3
Oh,
minus
yeah.
4, and I would know that it looks, okay, let's draw the axis of symmetry through that. So I know it's a parabola that goes through this point. I just don't know whether it's skinny or wide. And the last question, I've answered 2 of the questions, but I don't
Yep.
know where the y or the x-intercepts are. So how do I get the x-intercepts?
Um,
What does it mean to be an x-intercept? What does it say about y?
I
In other words, our parabola is going to look, I'm going to draw just an approximation here. I'm trying to find these points. What is y on both of those points?
um Y would be 0.
Yeah, x-intercepts, y is always 0. Y-intercepts, x is always 0.
Mm-hmm.
So whenever you're solving for x-intercepts, if I want to solve for these 2 points, I just make that 0.
Uh-huh.
And now, need room to write. So I'm solving this equation. So go ahead and solve this equation. First step,
Um, Wait.
yeah, you're solving this.
Okay, so then half of 3 is 1/2.
hold on.
or
No, we're not
3?
completing the square. We're solving the equation.
Oh, oh, so easy stuff. Okay.
Yeah.
Add 4 to the other side. That's what I would do. 4 equals x minus 3 squared. So then take the square root of that
Okay.
whole thing.
What's the next line?
And then you're going to have 2 equals x
Actually,
minus.
a good thing to remember is that whenever you are solving an equation by taking the square root of both sides, always begin your answer with the words plus or minus.
Oh,
Because when I take the square root of the left side, my answer is plus or minus 2.
plus minus 2 equals x minus 3. And then add 3 to 2, then plus minus 5. Oh, no. Plus minus 2 plus 3.
Okay, so what are my two answers?
And then you'll
That's one
have,
answer, and that's the other
yep, and
answer.
then you'll have x equals 5 or x equals 1.
Yeah. So now I know exactly how to graph it. I started at 3 comma minus 4, and I know it goes through 1 and it goes through 5. So I have my 3 points that make up parabolas, that define a parabola. I don't mean to make that look like a V. It is rounded there. So I'm able to do everything they ask. I know the axis of symmetry, the vertex, and I know 2 other points. They usually always ask you for 3 points. They'll either ask you for the vertex and the x-intercepts, or they might ask you for the vertex and the y-intercept. And the y-intercept is really easy because all you do is plug in 0 for x. In other words, if you recognize that the y-intercept means x is 0, plug in 0 for x, I know the y-intercept instantly is 5. It's 0 minus 3 squared, which is 9, minus 4, which is 5. So the y-intercept is much easier to get than the x-intercepts, because when you plug in 0 for x, this is a real simple problem. Whereas when I plug in 0 for y, we have to go through all of that math to solve for x.
Uh-huh.
But it's really useful. For some reason, I get quite a few students who don't remember that you work so much with x-intercepts, and most all students will know that x-intercepts means y is 0. But if you take that same student and you say, okay, so what's the y-intercept mean? They won't know. And it's great to remember that x-intercepts means y is 0, y-intercepts means x is 0. So remember those two things.
Yes, I
Okay.
will.
All right. So that's a good place to stop. Now,
All right.
are you ever going to get review material in the near future, or are we always going to be
I am gonna reach out,
okay? It's
go to the
better
school,
if we
request it.
Yeah, it's better actually for you if you have review material that we can just do step by step. Um,
Yep.
just because that's the way they'll teach it to you when you take your class. Whereas the way I'm teaching it to you is the way I would teach algebra to somebody if I didn't have a book and they didn't know anything. And it may be a little different. So um, I'm still trying, like today, I went through the 3 formats of quadratics. That's probably the way they would teach you also, but maybe not. They might just teach you the vertex format and then have you do a lot with that. So if you have a chance to actually get some review material, take a picture of it, send it to my email address, and then when we do a session, we can just pull that up on our screen and go through each, 1, 2, 3, 4, 5. But even if you can't get that, I can still help you. I mean, I've tutored algebra for 14 years now, so I'm pretty much sure of how they teach it, what the curriculum would be. Any
Uh-huh.
questions before we sign off here?
Nope, not at all. Thank you so
Okay.
much.
All right. Sorry for all the confusion today, but
Oh, no, that's all right.
yeah, let's see. In terms of, there's one more link, if you have a second here, that it's probably worth showing you. I use a scheduling program outside of Wyzant. Wyzant has a calendar, but it
Uh-huh.
is not synced with my calendar that I use. I have a website that I do a lot of math tutoring on, and I have a calendar on there. Here, let me take it. Let me go there and I'll show you, and then I'll send you the link and I'll show you what I'm talking about here. My website is digitalmathtutor.com. And that's me. Scroll all the way down to the bottom. You'll see this book now from the front page. This allows you to schedule sessions, and it'll show you my complete availability, and you can schedule it anytime you want. Now, it does use mountain time. Where are you located?
In Colorado.
Oh, okay. So
Yeah,
you're good to
you're
go.
in Littleton or something, right?
I am. Yeah, in King
All
Carl.
right. I'm in Evergreen, so
Oh, okay. We're not that far away, really. Evergreen's like 20
nope.
minutes. But anyway, I clicked on the book now, and you'll notice that it gives me all of these options. I teach bridge also. Let's say you want to do uh, an hour-long math session. So you choose this one up here. You would hit book. It's going to give you a calendar next. Well,
Okay.
uh, makes you sign in, uh, which I don't want to do.
But would
Um,
that make me re-sign up and have to like pay again for these
no,
classes?
no. Well, you won't pay through my website. You'll just schedule. And
Oh, all right.
the beauty is that you don't have to talk to me to schedule, because when you use this book now, this scheduling app on my website, it'll show you my complete availability, and it'll
All
let you
right.
pick whatever time I'm available that you want. Let's say you wanted a session for next Tuesday at 4 o'clock, and you look next Tuesday and I'm available at 4, you just click on the 4 o'clock time and it will send me a text saying you scheduled a 4 o'clock session. And so it can be quite difficult to describe one's availability. If I have, 2 hours here and then a 3 hour break and then an hour scheduled and then a 4 hour break, it's next to impossible to describe your availability to a person verbally.
Yeah.
Using this scheduling app shows it to you and makes it
Awesome. All right.
really, really easy. So you can schedule without talking to me. We don't need to exchange emails or anything. And I will get a text when you've scheduled a session, and I'll know to send you a Zoom invite 10 minutes before that session, and then we'll have our normal session. And then at the end of the session, I will go into Wyzant on my own and bill and get paid by Wyzant for the session. So
Uh-huh.
trust me, that it might not look like it, but it is a far easier way for you to schedule sessions. Once you get through this login, which I don't like, I actually hate this Booksy, but I used to use a different scheduling app and it got bought out by Booksy, so I'm kind of stuck with them now. But once you get through this, the next time you won't have to sign in. It'll recognize you, and you'll go straight to my availability, pick a date, It'll give you my exact availability on that day. I'm available from 8 a.m. to 9 p.m., 7 days a week, and you can schedule like that. So
Mhm.
you probably don't need me to send you a link. A digital math tutor. There's only one way to spell those three words. Um, you need me to send you a link, or is that something you can remember, or you tell me. I can easily send you that link, but
Huh?
you want
I'm
me?
all good. No,
You're
I'll
good?
switch.
Okay.
Yep.
Okay.
So awesome.
Okay. Great. Mila, have a good rest of your week, and we'll talk to you next time.
You as well. Have a good one.